Hello everyone, welcome back to another video. We are going to dive into the 2018 Year 6 SATs Arithmetic paper for maths. Let's dive straight in. So, question 1, I'm going to show you how to answer these questions, what the correct answers are, and get you ready for future SATs papers that you might be sitting. So, 673 plus 39, classic question here where the numbers have a different amount of digits. So just make sure you're lining up the hundreds, tens, and ones correctly. Once you do this, it should be quite straightforward. In the ones column, we have 12, so we exchange over. 7 plus 3 is 10, plus the 1 is 11. Get rid of that one because I've added it on. And then 6 plus 1 is 7. So we've got the answer there, 712. Simple as that for the first question, but as you see, it will get trickier. 9/11ths subtract 4/11ths. Big thing we notice, guys, is that you are sometimes in such a rush that you miss the symbol. It's subtraction. Now, luckily for us, the denominators are the same. They're both 11, so that means we can just look at the numerators. 9 take away 4 is 5, so we have 5/11ths left. When the denominator is the same, subtracting and adding fractions is super simple. Think of it like 9 tables take away 4 tables. 9 Dylans take away 4 Dylans. We'd have 5 left. So 5/11ths is the answer. Question 3. Let's take a look here. 2 times 45. This is quite straightforward. Doubling. So all we have to do here to double is we have to take 40, and double that. 5 and double that is 10. You could do it mentally and get 80 here with 10 there. Or you could set it out in short multiplication. I'd be doing this one in my head. 80 plus 10 is 90. So double 45. Think of it like that. Try and use some strategies to help you with those kinds of questions. Let's take a look at question 3 now. 838 divided by 1. Well, it really is as straightforward as just putting down 838. Simple rule, when you divide by 1, you're asking yourselves, how many ones are in that number? Well, it's the number because that's the definition of it. So there are 838 ones in 838. If you divide anything by 1, the answer is the first number you started with. Question 5. 99 divided by 11, times table facts. I'm not going to sit here and teach you all of your times tables right now. You have to learn them both going forward, multiplication, and backwards using division. There are 9 11s in 99. Question 6, multiplying 3 numbers together. The cool thing about this is you can do it in any order you like. You'll still get the same answer. I am going to do 5 times 4 first though. 5 times 4 is 20. And what I like to do is just cross it out when I found the answer to that. And I'm left with 20 multiplied by 10. Be careful. Don't start adding randomly halfway through. 20 multiplied by 10 is 200. So we have to be really confident with our times tables there. Obviously 20, we don't go that high in our times tables, but multiplying by 10, that's why I left it until the end. To make a number 10 times bigger here, we can shift the digits up the place value chart and add a placeholder in the ones column. The answer to question 6 is 200. Let's go to question 7 now. Again, similar to the first question, we are given 2 numbers with different numbers, a different number of digits. So we have a 4-digit number and we have a 3-digit number. Guys, just make sure you are lining up those digits perfectly. Then we can subtract. 4 take away 2 is 2. 6 take nothing is 6. 0 take away 5 is not 5. Don't just swap them because you fancy it. If you have nothing and you take away 5, that doesn't work in column subtraction. We can't have negative numbers. So instead, as you know, you would have practiced this lots and lots. We can use exchange. 10 take away 5 now is 5, and left in a thousands column is 6. We have 6,562 as our answer. So far, relatively straightforward. The only mistakes we might make are simple little tiny ones. That's why we must check our answers, guys, when we're doing tests. 6 and then a small 2 at the top. Again, you need to know what this means. This is a squared symbol. When we square a number, we multiply it by itself. So 6 squared is 6 times 6. You have to know your times tables, simple as that. 6 times 6 is 36. Then we're going to add the 10 on and we get 46. Next one, question 9. Again, decimals, but what's the classic trap? Different number of decimal places. So it's all about place value. I like to put my decimals in first because I know they must line up. So I'm going to write down 56.38. And I'm going to make sure now the next number lines up with the decimal. So the 7 is in the 10th column. I've got 24. And you'll notice there is a gap here. We're adding, okay? And if you see a gap here with decimal places, you can put a placeholder in if you want to. A 0, that's up to you. Now we've done this, we just do simple addition as we would if there wasn't a decimal place there. 8 plus 0 is 8. 3 plus 7 is 10, so we exchange past the decimal point. 6 plus 4 plus 1 is 11. 5 plus 2 plus 1 is 8. Now, our answer is not 8,108. I see this a lot. careless copying, because remember, the decimal point makes the number completely different. 81.08 is very different to 8,108. Question 10, we've got a bit of an inverse operation here. We start with something and we subtract 10 to get 298. So we're working backwards using the opposite, using the inverse. We're going to add 10 back onto our answer. So 298 plus 10. Again, whatever you do, just make sure you get it right. You could just jot this down. If you really wanted to make sure, of course you could do this. You'll get 10 there and you exchange over. Hopefully though, by this point, you've developed those mental strategies to save time. 29 tens, you could think of it like that, because 9 tens would creep over into the hundreds. 29 plus an extra 10 is 30 tens. That's where we get the 30 from here. However you did this question, guys, the big thing is you need to use the inverse. Okay, don't just take away 10 from the number you see. That would give us 288. If we put that in the equation, then it breaks. It just doesn't work. So let's take a look now at question 11. 270 divided by 3. Now, you could use your short division. However, it's designed for you to be doing it quickly. Imagine this number was just 27 and you know your times tables. How many 3's in 27? Well, the answer is 9. But the question didn't say 27 divided by 3. It said 270 divided by 3. It's 10 times bigger, so you must do the same to your answer. The answer here is 90, not 9. Next one, question 12. Same exact principle. Treat it as 54 divided by 9. How many 9's are in 54? Excuse me, there are 6 9's in 54, but the question didn't say 54 divided by 9. That's just what I'm using to calculate it mentally. It's 100 times bigger, so I make my answer 100 times bigger as well. The answer here is 600. So 2 questions in a row, relying on you guys knowing your times table facts and working mentally. 60 divided by 15. Again, you might not know your 15 times table, but what you can do is just count up in 15s. 1 15 is 15. Add on another 15 is 30. Add on another 15 is 45. And then finally here, we're going to end up with 60. As you can count, 1, 2, 3, 4 lots of 15 and 60. So the answer there is 4. You'll notice, guys, I am literally a teacher of maths to primary school children, and I still write down all of my working out. You should too. I promise you it's going to help you get rid of some silly mistakes for sure. Question 14. Again, does it matter that the answer is here? No, because look, this is still our number sentence, okay? Our operation rather. 5,776 take away 855. Did you notice the trap yet? They're always doing this, guys. You need to be really confident at lining up your digits, because they're always going to try and trap you. That's just the way it is. So line up your hundreds. The 855 would go here. And just check that symbol. Be careful. I bet you've all done it before. You've just rushed ahead and done the wrong operation. Done some really good maths, but not got a mark. 6 take away 5 is 1. 7 take away 5 is 2. 7 take away 8. We can't do it in our column method. So we go to the thousands column and exchange over. Now we've got 1700 to take away 8 is 9. And then 4,000s left over. The answer is 4,921. Just be really careful when you're copying your working out answer into the box. If you copy incorrectly, you risk losing a mark. This is a place value question. We don't need to do any formal methods here. Let me show you how. 3,050,020. Now we've got the 3 million here. So this 3 is accounted for. We've also got 20 over there. So this 2 is accounted for. Now the rest are placeholders apart from one digit, and that's the 5. So think to yourselves, what is this 5 worth? Is it worth 5 1s, 5 10s, 5 100s? Well, this column is the 10,000s column. So we have 5 lots of 10,000. That is 50,000. So no formal method needed there, just a case of looking at which place value columns were represented and which weren't. Question 16. 10 subtract 5.4. Now there are a number of ways to do this. I like to split 5.4 up into subtract 5 and then subtract 0.4. So this starts off as a really simple question for me. I do 10 take away 5 is 5. Then I've got to subtract 0.4. Now I know, because I'm taking away less than 1, the answer is going to be 4 point something, and I can use my number bonds to 10. I've taken away 4 tenths, so there'd be 6 tenths left over. 4.6. You could put it into column method if you like and do exchanging. No problem with that. This is how I do it quicker with my mental strategies and my number fluency. Question 17. 5 sevenths plus 3 21sts. I suppose that's how we'd say that. Guys, we cannot do this without first converting. Denominators have to be the same. So I notice straight away 7's going to 21. How many times? 3. So I'm going to convert 5 sevenths into something over 21. Once I've done that, I can solve the question. As I said, I noticed that it's multiplied by 3. Do the same to the top to make sure the fractions are equivalent. 5 times 3 is 15. So we can erase 5/7 and swap it for 15 21st because they are worth the same amount, but now the denominators are the same. I can just look at the numerators. 15 plus 3 is 18, and then the denominator is going to say 21. So straightforward there, just an extra step added in. Question 18, dividing and multiplying by 10 or 100. When you see this, dividing or multiplying by 10 or 100, you know you're just moving digits, okay? So here is 0.1. I'm going to underneath keep my decimal in the same place. This is the ones column, this is the tenths, the hundredths, the thousandths, and it keeps going down as we know. Now think of it this way, dividing means our numbers getting smaller, so we're going to shift our digits down the place value column. How many places? Well, take a look, divide by 100. 2 zeros give us an indication that we're shifting it 2 places in our place value chart. It's a nice little trick to remember there. So this 1 here has to shift 2 places down. From the tenths to the hundredths would be 1 place, to the thousandths would be 2 places. Once we've done this, we can't just put 0.1 because that's wrong. We have to make sure every single one of those columns is respected with a placeholder. So the answer here is 0.001. We have to have mastery over this place value table, guys, to get these questions right. Question 19, 3/4 of 1,000. Now, when we're finding a fraction of an amount, we have to divide by the denominator and multiply by the numerator. So 1,000, I'm going to whack it into short division here to make sure. I like to just take notes, as you guys well know. Let's split it into 4 equal parts because our denominator is 4. 0 with 1 exchanged over. How many 4s in 10? 4, 8, 2 4s. And if I'm at 8, there's 2 left over. How many 4s in 20? That's 5 4s. And left over is just a 0, 250. So I know 1/4 is 250, but the question did not ask me for 1/4. The question asked me for 3 of them. So I need 3 lots of 250. Now, because I know the pattern of my 25s, I can do it really quickly in my head. 750 is the answer. If you don't know that pattern of 25, 50, 75, learn it. But most importantly, you could have just put it into short multiplication. You would have got the same answer. Next up, 20. Notice this, show your method. This is because when we have long multiplication or division, you are sometimes awarded marks for your working out. So here in long multiplication, we're multiplying by 23. The first row is going to be multiplying by 3, get 3 lots of the top number. The second row is going to be multiplying by 20. Once we have 3 lots and 20 lots, we can combine them and add them together. So for now, I'm just going to draw a line here because I'm at the phase of just setting up this question. 3 5s are 15. 3 8s are 24, but remember that exchange that I had to make with the 15. So 24 plus 1 is 25, and then exchange over the 2. 3 times 7 is 21, plus the 2, that gives me 23. So at the top there, I've got 3 lots of 785. Now I'm going to do 20 lots. Here's the problem. I want to just do 2 lots. So in order to be able to do that, I need to put a placeholder in. Make the answer 10 times bigger to start with. Now I can just concentrate on the 2. 2 times 5 is 10. So put in that and exchange over. 2 8s are 16, plus the 1 is 17. 2 7s are 14, plus the 1 is 15, and I've still not done. Now I need to add up to find the total. 3 lots plus 20 lots will give me 23 lots. So in the ones column, I've got a 5. I've got a 5 in the tens column. 3 plus 7 is 10, so I'm going to exchange over. 2 plus 5 plus 1 is 8. And then finally 1 in the 10,000s column, and that's my answer. You could just copy it into the box. Must show you working out for those questions, guys. Make sure, because if you make a little mistake, look, you could still get 1 mark if you show the correct method with 1 small arithmetic error. Question 21, 20% of 1,200. Now, when we're finding a percentage of an amount, I like to find 10% first, because 10% of a number, we divide the whole by 10. If that's 100%, to get 10%, we're going to divide by 10. So 10% here is equal to 120, but I don't want 10%, I want 20%. Well, I know 20% is just 2 lots of 10. So I double 120 and I get the answer 240. Next up, here's the long division. Now there are lots of ways to do this, okay? I like to write a little fact box over this way. 1 lot of 43, because guess what? I don't know my 43 times table. It's 43. 2 lots of 43 at 86. Now I noticed something straight away. 43s into 6 obviously don't go. So we're going to look for 43s into 64. That is just 1 lot because 2 lots is 86. 2 lots of 43 is too much. So we're going to put in one lot of 43 and we're going to subtract that 43 away. So 4 take away 3 is 1, 6 take away 4 is 2, and then we bring down the 5. So we've got one lot of 43 and 64 with 21 left over, and then we bring down the 5 to make 215. Now we need to keep going to see how many 43s are in 215. Now what I also do sometimes is I skip forward. I do 10 lots. 10 lots of 43 would be 430 because I don't need to count then. I can just multiply it by 10. And once I've got 10 lots, I can actually halve it to get what 5 lots would be, because half of 10 is 5. Half of 430 is 215. And look why I'm showing you this. This is a shortcut. Look for them at all points. 5 43s and 215. So actually we match up perfectly with nothing left over, and that's going to be 5 lots up here. So the answer to this question was 15. Good evidence there of how finding a quick and easy way, a strategy of saving time is going to help us lots, especially in these trickier questions. Question 23, 0.5 multiplied by 28. Now, there's quite a lot of ways we could do this. We could make this 10 times bigger, and we could do 5 times 28, and at the end, make it 10 times smaller. However, I want you to notice something about 0.5. 0.5 is equal to 1/2. And if we multiply, that's the same as saying of. We could say half of. 0.5 multiplied is the same as saying half of. That's going to save us a lot of time, because really what this question is asking us is half of 28. If we know that shortcut, we can get to 14. It's a really nice shortcut. Question 24, 1/2 plus 1/5. Now here's the problem, 2 doesn't go into 5. So we're going to have to find a common denominator where we could change 2 into that number and 5 into that number. And I'm thinking straight away, I'm just going to multiply them together to get 10. Then I know that 10 is a multiple of 2 and a multiple of 5. What did I do to 2 to get to 10? I multiplied it by 5, so do the same to the top. Then I'm going to do over here, how did I get from 10 from 5? I multiplied that by 2. I multiplied this by 5 is what I meant to say, sorry. So multiply the top by 5. Then I'm going to multiply both the numerator and denominator here by 2, and I get 2/10. This is the exact same question. They are equivalent. 1/2 is the same as 5/10. 1/5 is the same as 2/10. But now the denominator is the same, which we talked about earlier is the most important thing. I can just tell you guys that the answer to this question is 7/10. Next up, question 25. 1 3/4 plus 3/4. Now, I'm going to draw this. There's lots of ways that we can answer these questions, right? I'm going to show you as many different ways as possible today. So 1 3/4, there's my 1 whole. Now I want 3/4. So here I've got 3/4 shaded. That's 1 3/4. I want to add on 3 more quarters. So let's just cut this into quarters and this one into quarters. I want to add on 3 more quarters. I'm actually going to show you now in a different color. So let's get red. Let's add 3 more quarters. There's 1 more quarter, 2 more quarters, 3 more quarters. So I've just done 1 3/4 plus 3/4. So I'm going to change back to blue quickly. Can you guys see, hopefully, how we can just answer the question now? We have 1 whole plus 1 whole plus 2/4. So we have 1 plus 1 plus 2/4. That means we have 2 wholes and 2/4. If you wanted to, you could write it as 2 wholes and 1/2. They are the exact same. But look, just another method, right? Or just another method. I like it. It's very visual. It might help you guys at home. 6 subtract 5.738. Now, there are mental strategies to this you can count on. I'm going to show you a strategy that works every time. It might take a bit longer, but if you've got that spare time in the test because you've been using other strategies, this is going to get the right answer every time. So at the minute, this looks ridiculous, doesn't it? Because 6 would go in the ones column. There's my decimal place, the tenths, the hundredths, and the thousandths up there. Now, here's the problem. Blank take away 8. Well, I've already told you, put your decimal place in so they line up, but you can put placeholders in here of 0. This is where this question gets messy, okay? So 0 take away 8, we can't do that. We need to exchange. So look in the hundredths column, but we got nothing. Oh dear, well, we need something in the hundredths column. That's fine. We'll go to the tenths column, and there's nothing. So we need to go all the way to the ones. We're going to take a 1, and now we have 5 ones. Do not go straight to the thousandths. That makes no sense. There are not 10 thousandths in 1. There are 1,000 thousandths in 1. So we have to do 1 jump at a time. Now we have 10 tenths. That's 1. I'm going to take away 1/10. So left with 9. Now I've got 10 hundredths. Now I can take away 100th, and I've got 10 thousandths. And now we can answer the question. 10 take away 8 is 2. 9 take away 3 is 6. 9 take away 7 is 2. Put your decimal place in. 5 take away 5 is 0. The answer here is 0.262. That's going to get you the right answer every time. It can be quite time consuming, but if you master this method, you're going to get a mark every single time. Question 27, 3.9 times 30. Now, 3.9 I'm going to keep the same, but I'm going to split 30 into a factor pair. 30 I can split into 10 times 3, because 30 is the same as 10 times 3. So I can do that. That's fair. If we have that knowledge, it makes this question really easy. Now we've got 3.9 times 10 times 3. You'll remember earlier on I said we can do it in any order. I'm going to do 3.9 times 10 because that gets rid of the decimal. That leaves me with 39. And I've still got to multiply by 3. Now it's just a straightforward question. You can whack it into a short multiplication question and it shouldn't be too much bother. 9 times 3 is 27. Sorry, that's a 7, 27. 3 times 3 is 9, so that's add the 2 is 11. 117 is the answer. So really, it's all about knowing and having a mastery of numbers going to get you shortcuts in the arithmetic paper and your SATs, guys. Question 28, 1 and 1/15 take away 2/5, sorry. So we've got a problem here. We've got a mixed number and a normal fraction, and the denominators are different. So first thing, I'm going to change this into an improper fraction. So I know that 1 whole is the same as 15/15 plus an extra 1/15. So what we've got there is 16/15. I'm going to subtract 2/5. Now again, I can't do this. I need to make sure my denominators are the same, but luckily 5 goes into 15 3 times. So I'm going to get rid of 2/5 and I'm going to multiply the bottom denominator by 3, do the same to the top to make sure the fractions are equivalent. Now I can subtract 16/15, I can subtract 6/15 from 16/15. That's going to give us 10/15 as our answer. Again, if you wanted to simplify, you could write this as 2/3, but both are correct. Question 29, we're back with some long multiplication. Remember, this line we're going to multiply by 6, this line we're going to multiply by 8. Let's go. It's going to take time, but we have to be really confident with our times tables. 6 3s are 18. 6 1s are 6 plus the 1 is 7. 6 4s are 24. And 6 5s are 30 plus the 2. So that's 32. Now we're going to make this 10 times bigger because it's not times 8, it's times 80. So this is what our 0 does, makes us be able to concentrate on the 8s now. 8 3s are 24. Exchange over the 2. 8 1s are 8, plus 2 is 10. 8 4s are 32, plus the 1 is 3. So that's 33. 8 times 5 is 40, plus the 3 is 43. Now we have to add up these two amounts to get 86 lots. 8, I'm going to do it right into the box. In the 1s is 8, in the 10s is 1. We exchange over 1 here. That's going to be 5 in the hundreds. We're going to get a 5 in the thousands, a 3 plus 3, which is a 6 in the 10,000s, and a 4 in the 100,000s. 465,518. Guys, if I was you, write it in there first, then just copy it in. Okay, I was trying to be clever then. Look, it nearly backfired. It nearly backfired. So, next one, question 30. 99% of 200. What do you notice about 99? I notice it's very close to 100. In fact, it's only 1% off. So let's work out what 1% of 200 would be. Well, if 200 is 100%, 1% we divide by 100. So 200 divided by 100 is 2. 1% of 200 is 2. And then all we need to do is take it away. If you take away 1% from a number, you're left with 99%. So the answer here is 198. A real good shortcut. Saves us trying to build 99, which would take forever. 1/4. Oh, divided by 2. I love this question. So let's think of it this way. 1/4 divided by 2 over 1. Because that's what a whole number is. It's the number over 1. Now we've done this, we can actually cross multiply. Okay, we can flip it upside down and multiply. What do I mean? We'll keep 1/4 and we can multiply if we swap over this 2 and the 1. So it becomes over like this 1/2. Amazingly, we can now just do 1 times 1 is 1. And for the denominator, 4 times 2 is 8. 1/4 divided by 2 is an 8. And if you really think about it, it's pretty obvious, isn't it? If we have a quarter here and we split this quarter, we divide it in 2, we split it in half, It's going to give us a smaller amount. It's going to give us an eighth. So that's the answer to that question. 32. We discussed this earlier. This 2 is a square symbol. 9 times 9 is 81. So we're going to do 81, subtract 36, divided by 9. Now, what's really lucky is I was following the order of operations already. BIDMAS, BODMAS, whatever you want to call it, there is an order that we do things. Brackets and indices. Now, here the square counts as an indice. So any square would count as an indice. You do that first with brackets. Then we do division and multiplication. Notice here, subtraction actually comes first in the number sentence, but we need to ignore that because division has a higher priority. So we do 36 divided by 9 is 4, which means we're left with 81 divided by 4. Then look at the end, subtraction with addition. Now we can subtract 81, subtract 4 is 77. So that's the answer to that one. Next up, question 33. 1 and 1/2 multiplied by 40. Well, we can partition this. Okay, there's a number of methods you can do this. 1 times 40 is 40. And then we want to do 1/2 times 40. Now we spoke about this earlier. That multiplication symbol can mean of. So we can interchange those two things and it becomes a lot easier. Half of 40. Half of 40 is 20. So 40 plus 20, that gives us 60 as our answer. Question 34, 28%. Now we are going to have to do some building here. Okay, it's as simple as that. So 650. Let's think, what's 10% going to be? Well, 10% divided by 10, we're going to get 65. So what's 20% going to be? Because we want to get closer, don't we? 20% is going to be double 65, which is 130. And again, I'm actually going to go to 30% because 30%, that gets us really close to 28. We add on another 65, we get 195. Now, we're at 30%, we want 28%. So we're going to subtract 2%. So 1% is our building block. 1% of 650 is 6.5. 2%, therefore, is double that. We're going to get 13. We could have divided by 10 here as well. But either way, 2% is 13. So now I'm left with 195 is 30%. Take away 2%, which is 13. And that's going to give us 28%. 5 take away 3 is 2. 9 take away 1 is 8. 1 is just left there. 182 is the answer. There's lots of ways you can build up to a percentage question, whatever you're comfortable with. But you need to be able to find 10% and 1%. That's the minimum. Okay, that is the absolute minimum. Next question, 35. Again, just annoying fractions. Let's make them equivalent. So we have 4 2/3 and 1 6/7. Well, we're going to multiply 7 and 3 to make sure we get a common denominator of 21. We did 3 times 7, so do the same to the top. We get 14 over 21. So it's 4 and 14 over 21. Subtract 1 and do the same over here, multiply it by 3, 18 over 21. So what do we do now? Well, it is just straightforward. It might get a bit complicated, but at least the denominators are the same. One thing we can do is to make them both into improper fractions. The other thing we can do is do 4 take away 1 first. That leaves us with 3 and 14 21sts. Subtract 18 21sts. And we could just partition it and work from there. Let's do that method. So 3 and 14 21sts. Take away 18 21st. Well, I'm going to take away 14 21st to cancel that out. And we're left with 3 take away 4 21sts. Because you can see here, if I've used 14 21st up to get rid of this 14, I'm left with 4 21st there. And the final answer would be 2 and 17 21st. There is another method, guys. You could, at this stage, or even earlier, however you like, you could change them into improper fractions. So here we could say 4 times 21 is 84. Plus the 14 is 98. So we'd have 98 over 21. And we could subtract here 21 over 21 would be 1 whole. So then we'd have 39 over 21. And you could go like that and derive it and eventually get to the same answer. However you did it is a complicated question. You have to have a real mastery of fractions to answer it carefully. So the answer is 2 and 17 21st. Here we go. Long division. Again, 97. I just like to make a fact box over here. But before I carry on, I'm going to see if I can spot anything. And now look at this. 97 into 8 doesn't go. 97 into 88 doesn't go. So we're looking at 882 here. That is a huge number. So I'm going to skip straight down to 10 lots. 10 lots of 97 is 970. Now I'm going to find 9 lots of 97 now. and I can take away 97 from 970. And I'll end up with 800. And that's taken away the 70 gets me to 900. Then I need to take away another 27. So that gets us to 873, which is perfect. We want 873 because it's very close, but not above 882. So 873 here, subtract, and that is that is 9 lots of 97. Let's see what we're left with when we subtract here. 2 take away 3 we can't do, so we're going to exchange. We get 12 take away 3 is going to give us 9. Look at this. They cancel, bring down the 7. Guys, how many 97s are there in 97? Yes, obviously, just 1. So that gets us a perfect answer there of 91. So although the first step was quite annoying, you had to go to 10 and count back, the final step was relatively straightforward. The answer there is 91. My goodness, huge number. And that's the end of the test. So what I wanted you to get from that was hopefully a really good understanding of what to expect on a SATs paper, and also the understanding that with really good number sense and knowing these strategies at the back of our hand and knowing our times tables and all of the basics, we can save time, and jotting things down is vital. It is absolutely vital. So guys, hopefully you found that useful, and I'll be back soon with paper 2, which is some reasoning. See you then.